In 9.5 logarithmic functions, we're going to take a look at why it's important to use logarithms and how we can change a logarithmic function into an exponential function and vice versa. So to kind of see why logarithms are important, let's think of the function 2 to the x power. If we were to make a t-chart and look at the graph, you would kind of see what you see on your screen, this exponential blue line. And because it passes the vertical line test and the horizontal line test, we know that it's a one-to-one function, which means it has to have an inverse. And what we talked about in past sections is reflected over the line y equals x, we could draw what that inverse function looks like. But we really want is an equation for it. And if we try to do that based on what we did before, you'll see that we run into some problems. Y equals 2 to the x power. And if we exchange x for y, and we try to solve for y, we really don't know how to get rid of it. Because normally if it was if it was something like x to the third, we could do the cube root or so forth. But we don't know what this is. It's an unknown number, and it also is dependent. It moves all the time, so there's not a specific number. So how do we get it out? At this point, we're going to use logarithmic notation to get that y out of the exponent. Logarithmic notation is really the power to which b is raised to produce a result of x. So as you can kind of see how they're interchanged right here, that y equals log of x base b, which is going to be the same as x equals b to the y power. So if we look at the exponential form that we had previously, b that base, as we would say normally for exponents, becomes the base of the log. That's that little subscript right there. It will equal to the exponent, and whatever the log of that base is, that's where x is. How would we read this is the log of x to the base b. What we're going to do for the rest of the section, or this lesson, is we're just going to change exponential equations to logarithmic and vice versa. So here, we're going to write these as exponential equations. So this 7 right here becomes the base of the exponent. The 2 becomes the exponent. And the 49 is what it will equal. Now, if you take a look at that, that should make sense. 7 squared does equal 49. If I take log base 8 of 1/8 equals -1, 8 is the base, -1 is the exponent, and it equals 1/8. Again, this should make sense because if I have a negative exponent, that moves it to the denominator, which then you can see it makes it equal. Pause the video and do number 3 and 4 and change them into exponential equations. Alright, these are the answers you should get for 3 and 4. 3 to the 1/2 equals the square root of 3, and 12 to the 6th power equals x for number 4. For the next 4 examples, we're going to go the opposite way. We're going to change each of the exponential equations into logarithmic equations. So for number 5, we have 3/4 equals 81. I'm going to write it as a log, and the base is the base of the exponent, which is 3. The exponent is what it will equal, and the 81 is the of part. So log base 3 of 81 equals 4. I'm going to do the same thing with number 6. 2 to the -3rd equals 1/8. I'm going to do log base 2 of 1/8 equals -3. Again, pause the video for 7 and 8 and write each of those as a logarithmic equation and then check your answers. For number 7, you should have got log of base 7 of cube root of 7 equals 1/3. And for number 8, you should have gotten log of y to the base 5 equals pi. And the last part of this video is we're going to take a little bit of a preview of how we're going to evaluate these and actually solve for variables. So what we want to do is we want to evaluate it. We want to see what each evaluates to. So what we're trying to do is figure out what it equals to, which is an unknown. So I'm going to set that equal to x. There you can see it kind of makes a more complete equation where we can make it exponential. I take the 2 as the base, take the x as the exponent, I set it equal to 8. Now, like we did in the previous section, we're going to take 8 and change that into a base of 2 so that bases match up and we can solve. 8 is 2 to the 3rd. So I have 2 to the x power equals 2 to the 3rd. Since the bases are the same, I can look at the exponents, and x will equal 3. Or log of 8 base 2 equals 3. I'm going to do the next, same for number 10. I'm going to set it equal to x, write it as an exponential equation, and then solve. I know that 9 can be written as 3 to the second, and to get it out of the denominator, I can make it negative, so it's 3 to the negative second. Therefore, x equals negative 2, or log of 1/9 base 3 equals negative 2. Pause the video and try number 11. And your answer for number 11 should be half. And you can see the work there on the screen.